Questions 21 through 25 of the 1998 Grade 9 Pascal Math Contest is what I will discuss. Question 21 says that Q is the point of intersection of the diagonals of one face of a cube whose edges have length 2 units. The length of QR is. All right, let's draw this out a bit bigger. So here's our cube, and I'm going to draw the diagonals now. There's one diagonal, and there's another diagonal. And this is the line that they are most interested in this question. And of course, this is Q, and this is R. So the only piece of information they've given us is that the cube has edges of length 2. So this is 2, this is 2, this is 2, and so on. You get the point. All the edges have the length 2. So how do we approach this? The best thing to do at the very beginning of the question is to draw a triangle. And I'll show you which triangle I'm referring to. From Q down to the base like that. And from R to the base like that. All right? If you do that, you will see that this is now a right triangle. Like this. And if you can then figure out the sides, you'll be able to figure out QR. Let's label this a little bit here. Let's call this P right here. And I'll call this S. All right? So essentially what we want is RQ or QR. And the relationship in this triangle based on the Pythagorean theorem is that that is equal to PQ squared plus RP squared. All right? And I'm going to systematically figure out first QP, PQ, and then I'll figure out RP. And then I'll come back to this, plug it in, and we can figure out QR. All right? So then the next step is I'm going to look at this face right here. But I'm going to draw it out flat so it makes a little bit more sense. So here it is, sort of head on. And this is, of course, the same. This is Q, and this is P. I've got to draw up that perpendicular to represent QP, like that. And we're going to try to figure out QP from this diagram. Now, the good news is that we can use the fact that 2 is the side length. If 2 is the side, then this is a perpendicular, so we've essentially just cut that base in half. So therefore, this is 1, and this is 1. Okay? And we also know that from here to here, this is 1. And that's 1. So this side is also 1. So we can use Pythagoras to figure out QP. But so the good news is we don't even need the Pythagorean theorem. QP is just 1. So that's good. So we can label that in there as 1. The length of QP. Now let's turn our attention to this triangle right here, RPS, that one right there. And I will draw it out a little bit bigger. So this is RPS, let's label it RP and S. And this is, of course, a right triangle. And the PS side is just 1, because from here to here is just 1, since QP, or point P rather, split that side into halves. And therefore RS we know is 2, so we can solve for RP. RP squared is equal to PS squared, which is 1 squared, plus RS squared, which is 2 squared. So this becomes 5, and therefore RP is the square root of 5. And I think we've got it all. We've got QP and RP. So we can go back and plug it into here. So QR squared is equal to PQ or QP, which is 1 squared. RP was root 5 squared. So we've got 1 plus 5, which is 6, and therefore QR is equal to the square root of 6. So the answer here is E. A deck of 100 cards is numbered from 1 to 100. Each card has the same number printed on both sides. One side of each card is red, and the other side is yellow. Barsby places all the cards red side up on a table. He first turns over every card that is number divisible by 2. He then examines all the cards and turns over every card that has a number divisible by 3. How many cards have the red side up when Barsby is finished? All right, let's first explain the question. So you've got 100 cards. Each card has red on one side, and on the back is going to be yellow. And in addition to colors, each card has a number, 1 through 100. Initially, he puts all 100 cards on the table like that, and all the cards initially have their red side up. All right, so initially you have 100 red cards like that. So this is red, this is red, this is red, and so on. That's the first step. And these cards are labeled 1, 2, 3, 4, 5, 6, all the way to 100. Then he turns over every card that has a number divisible by 2. So what basically is happening is that all the numbers that are divisible by 2 get flipped, and therefore they become yellow, like that. So when you do that, you basically have flipped over half the cards. So now you have 50 that are red and 50 that are showing yellow. Okay? So that is the first thing that he did. Then he looks at all the cards, and he then turns over all the cards that are divisible by 3. So at this point, we need to slow down and figure out what is going on. So if he's going to now flip over every card that is divisible by 3, then let's just quickly make a list of some of the numbers that are divisible by 3. You don't have to list them all, because you're going to have to go up all the way to 100. But these are the numbers that are divisible by 3, right? Now, all the way up to 99, because 100 is not divisible by 3. So how many of these numbers are there? 3, 6, 9, 12. Well, there's 33, and you can easily do that by 99 divided by 3. Now here's the key to the question. He's flipping over all of these numbers. So he's going to flip over this one, and so on. We have to break these up into odd and even. How many of these numbers are odd? That's important because currently in our diagram, the odd numbers are red. Currently, red. And our even numbers currently in our pattern are yellow. 2, 4, 6, all the way up to 100. So in this list, how many are odd and how many are even? Well, the even ones are 6, 12, 18, and so on, and there's 16 of them. And the odd are 3, 9, 15, 21, all the way up to 99, and there's 17 of those. So that basically means if you look at this right here, that of the 50 that are red, he is going to flip over 17 of those, right? Because those are the ones that are odd, like 1, 3, 5, and those are the ones that are divisible by 3. So 3, 9, 15. So if he flips over 17 red, it will result in there being only 33 red, and the remaining 17 will become yellow. Okay? Then, what about the next one? There's 50 yellows, and he's going to flip over 16 of them. So the 50 yellows will then become 34 yellows, and the 16 that are flipped will become 16 red. All right? So the question is asking you, when this is all done, how many cards have red side up? Well, we are done, and how many are red? Well, we have 33 red here, and we have 16 red there. So 33 plus 16 is equal to 49 red. And therefore the answer is 49, and that would be choice E. The numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 999, 999, 999 are multiplied. How many of the digits in the final result are nines? Okay, so we're dealing with some pretty big numbers here. And we're multiplying this by 999, like that. Now, of course, the immediate temptation is to run to your calculator, but I don't know what kind of calculators you all have nowadays, but in my calculator, this won't even go through. It's too big of a number. So what I did was I just multiplied this number by a manipulation of this number. And that manipulation is this big number minus 1, like that. And this big number, I believe, is 1 billion, if my math is correct here. So we've got 9 zeros, so that is indeed 1 billion. So if you have this big number multiplied by that billion, it just becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, followed by 9 zeros like that. And then this big number multiplied by -1 is just that number, but with a negative sign in front of it, like that. So now we can do this manually. And you might be able to do this on a calculator. I'm not sure how many numbers your calculator holds, but you can definitely do it manually without too much problem. So just like how you did in elementary school, you just put this beneath the number and then start subtracting, right? And if you do that, you'll get 1, 1, 2, 3, 4, 5, 6, 7, 8, and 8, and so on. This is the number. And we can complete this because what we really just did is we just figured out this part. The rest of the number is just the same as above: 8, 7, 6, 5, 4, 3, 2, 1. But we don't really need to be concerned with that. We just need to be concerned with this part. And if you look at this, you'll see that it has no nines. They're asking how many of the digits in the final result are nines. And there isn't one single 9 in this whole number. So 0 nines. So let's see if 0 is one of the answers, and it is. 23 is A. Three rugs have a combined area of 200 meters squared. By overlapping the rugs to cover a floor of 140 meters squared, the area which is covered by exactly 2 layers of the rug is 24 meters squared. What area is covered by 3 layers of the rug? All right, so let's say you have one rug like this, and you've got another rug like that, and you've got one final rug like that, and you're overlapping each other. So probably best to draw them in different colors. All right, so we've got this all drawn out. So as you can see, you've got a green rug here, we've got a red rug here, we've got this purple rug, or blue rug, whatever, and I've drawn them so that they overlap. So this part here I will call A, this part here I will call B, and in brackets I will write the number of rugs. So A is just one rug underneath it, which is the green rug. B, however, is 2 rugs, right? You've got the red rug and you've got the green rug, so that's 2 rugs. This part C is the part that is covered with 3 rugs. So we've got 3 there. And then the next one, D, is 2 rugs, and finally the last part is just 1 rug. All right, so I hope that makes sense. Now let's look at the question. They gave us quite a bit of information, so that's good. They told us that the area that is covered by 2 layers of the rug is 24. So in our question, that's B and D. So B plus D is 24. All right? Then they've also told us that the 3 rugs have a combined area of 200 meters squared. Okay? That will also help us. And I think one more piece of information. By overlapping the rugs to cover a floor area of 140. So that means that this whole thing is 140. So A plus B plus C plus D plus E is 140. All right. So I think that's all we know so far. Yeah. All right, this is what we're going to have to work with. Now let's look at this diagram a little bit closely. If you notice, just look at the green rug. What letters does the green rug encompass? Right here, this part here. It covers A, B, and C. So that means that A plus B plus C is the green rug. Okay, now let's look at it and see which letters represent the red rug. So the red rug is this one right here, like that. And those letters are B plus C plus D, which is the red rug. And finally, whatever color this is, I believe it's blue, what letters represent the blue rug? And that's C, D, and E. So C plus D plus E represent the blue rug. So we have 3 rugs. And I'm going to draw this over here now. If you combine the 3 rugs, you've got A plus B plus C plus B plus C plus D plus C plus D plus E. And they've given you the combined area of the 3 rugs. Very helpful. They've said it's 200. So we can put that into our formula, 200. Great. So now this, and this, these 3 equations we will use to figure out C, which is what they're asking for. They're asking for what area of the floor is covered by 3 rugs. All right, so first let's just simplify this one. I believe this is going to be A plus 2B plus 3c plus 2d plus e is 200. All right? And we can split this up into a plus b plus c plus d plus e, like that. And what's left is b plus c plus d plus c, like that, is 200. And the reason I did that is because a plus b plus c plus d plus e is 140. And then b plus d is 24. So b plus d is 24. And all you're left with is just 2 c's. So that will help us figure out the value for c. So 2c is equal to 200 minus 140 minus 24. And therefore 2c is equal to 36. And c is 18. So that's exactly what they're asking for. C, which is the area of the floor that's covered by 3 rugs, is 18. So the answer is B. One way to pack a 100 by 100 square with 10,000 circles, each of diameter 1, is to put them in 100 rows with 100 circles in each row. If the circles are repacked so that the centers of any 3 tangent circles form an equilateral triangle, what is the maximum number of additional circles that can be packed? All right, so let's not worry about the repacking. Let's just worry about how they initially packed it. Okay, so I'm certainly not going to draw out the 100 by 100. We'll just draw out a few. So they've got this way of packing these circles, and just really in a kind of a crude way, we'll kind of draw these circles in. All right, so they're basically saying that you've got these circles like that. You've got 100 by 100, so this is 100 and this is 100 in terms of its length, and you've got 10,000 circles, and in each row, this is a row, you've got 100 circles. So I've only written 6, but it just keeps going circle, 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 all the way up to the 100 circle. And similarly, each column will have 100, right? Because there's 100 like that. Okay, so that is how they're packing it, and they've told us that each is diameter 1. So the length from here to here is 1. So then, since the full height of this package is 100, there'll be 100 rows. And each of the 100 rows has 100 circles. All right? So now let's look at how are they repacking it. All right, so this is how they're repacking it. This is what they mean by this statement. The centers of any 3 tangent circles form an equilateral triangle. So this is a center, let's say, right here. This is a center, and this is a center. The centers form an equilateral triangle like that. All right? The centers of any 3 tangent circles. So they're tangent right here where they meet, right there. So this is the repackaging. Then they're saying, when you do this, how many additional circles can be packed? So initially we packed 10,000. By doing it this way, we're going to be able to pack more circles. All right, so how do we approach this question? Well, the first thing I want you to understand, which is probably a big part of this question, is in each row now, how many circles will you get? And that is an essential part of the question that I think a lot of students get wrong. The first row is the same. It was 100 before, it's 100 again, because the first row, remember, nothing's happened to the first row. Same thing with the third row. Nothing has happened to the third row in terms of its horizontal orientation. Vertical, we'll worry about that later, but let's just look at horizontally. But what about the second row? We've moved it. Do you see how we moved it there? So obviously, we're going to have less circles. How many less? That's the key to the question. The answer is 99. We had 100 before. By doing it this way, we're shifting it over just a little, and at the very end, it's going to be shifted over a little bit to the left, and that means there'll be one less. Now you might think, well, if there's one less, then how is it possible to have additional circles? If you're putting in less circles, then how is it going to end up with more circles at the end? That's another confusing part. Well, the reason you'll have more is because look at what happened. This got shifted up. Remember, before the circles were one below each other, but they're not one below each other anymore. Do you see how they got shifted up there? And that allows you to squeeze more in. All right? So that's a very key part of this question, is recognizing that that is 99. I really can't stress that enough, because otherwise you will never get any of these answers. You won't even come near these answers. Okay, now I'm going to very carefully draw in some important clues. The first is right here. That is what? That represents the radius of the circle, right? And they've told you that the diameter is 1. So therefore the radius is 1/2. All right? Now, is there anything else that's very obvious? Well, one thing is that we have to figure out what is the length of this right here, from there to there. If we can do that, that will help us greatly. And the good news is that we know the length from there to there. That's just the radius. So that's 1/2. And we also know the length from here to here. That is, look at this carefully, 2 radius. One radius from here to here, and then another one from there to there. So that means that is equal to 1. So this is a right triangle, and we can use the Pythagorean theorem to figure out this distance right here, which I will call h. All right? On the side here, we got h squared plus 1/2 squared is equal to 1 squared. And therefore, h squared is equal to 1 minus 1/4. So h squared is equal to 3/4, and h is equal to √3/2. All right? Now what I'm going to do is I want to end this row here before we get to the next row. So I'm going to draw a line like that. And therefore, I need to figure out this distance right here, from there to there. Okay? So I'm doing this slowly so that you understand. Now similarly, these triangles are also tangent to each other. So we can draw the same kind of triangular relationship that they keep talking about. And then from here to here is of course the radius, like that. And therefore, from here to here is also the same value. So if this was, let's say, 1/2, this part right here, then this is 1/2. Okay? And I'm going to write that in like that. And then from here to here, this whole thing, remember, is h, just like h up here, and therefore this here, from here to here, is h minus a half, right? Because from here to here is h, which is what we figured out, and from here to here is a half. So that is h minus a half. So the total height from there to there of the first two rows is very important. Well, we've got a half here. Height of a double row is equal to, we've got a half, we've got h from there to there, and h is equal to root 3 over 2. And then we finally got this part here, which is h minus a half. So root 3 minus a half. And this simplifies to just root 3. All right? So I hope you understood all that. Now we get to the next part of the question. Each double row has a height of root 3. Now what is the total length of this entire packaging? It's 100. They told you that, right? It's 100 by 100 square. So you have to fit in double rows of height root 3 into a height of 100. So how do you do that? Well, let's figure this out. If you have a square that is height 100 and each double row has a height of root 3, 100 divided by root 3 would give you the number of double rows. So if you do this, you will get approximately 57.7. And this represents the number of double rows. Okay? So we've got 57 double rows. And that would give us 57 times root 3 in terms of a total height. Each double row has a height of root 3, and there's 57 of them. And this is 98.7. Now remember, the total height of that square is 100. Can we squeeze in any more double rows? We can't. But we can squeeze in one more single row. Like that. Because a single row would probably be no more than 1. And that would bring us up to about 99. All right? So you understand what's happening. We've got a whole bunch of double rows here. And then we've got one final single row, which would be basically a height of 1, because that's the diameter of the circles. So this is the total. That's the total number of rows, 57 double rows and one single row. Now we come to the most important part, which I stressed earlier, is that we have to know exactly how many circles are in each row. Well, in the 57 double rows, how many circles did we have? Well, we had 100 and we had 99. Remember, that's very important to understand. In this part, we had 100, and in this part, we had 99, and that consists of a double row. So in each double row, we have 199. So the number of circles in 57 double rows is 57 times 199. Okay? Which is 1, 1, 3, 4, 3. And then we also have one more single row, and one single row would be 1 times 100, because remember, the single row just had 100. Nothing changed in terms of its horizontal outlook. So that's 100. Adding these all up, you get 1, 1, 4, 4, 3. So that is how many circles you can put into the square with this new orientation. And remember, initially there was 10,000, so they're asking how many additional did we pack, and therefore you just subtract them and you get 1443. So 1,443 additional circles. And that is choice D. And I just want to add one final addendum to this question, and I want to do that because I want this to make full sense. When you have a height calculation to pack a certain number of rows, let's say n rows, based on what I calculated, nothing else, just go back and look at what I did, the height is going to be 1/2 plus n minus 1 root 3 over 2 plus 1/2. All right? This is not some formula that they gave us. This is something that I figured out just from the diagram and the calculations. Now we have a total height of 100, right? The square was 100 by 100. So the height of all of our rows has to be equal or less than. It could be slightly less than. So then if you do the math here, you get n minus 1 root 3 over 2 plus 1 is less than or equal to 100. N minus 1 root 3 over 2 is less than 99. And if you do the math, you get n minus 1 is less than 2 times 99 over root 3. And this would be approximately 114.3 is n minus 1, and therefore n is less than 115.3. So the maximum n can be in terms of rows is 115. And that's exactly what we got. We got 57 double rows and one single row. 57 double rows is how many rows? Well, 57 times 2, which is 114. And one single row, of course, is just 1. So 114 plus 1 is 115. So it is exactly what this mathematical equation gives us. And this mathematical equation I figured out just entirely from our calculations up here. All right? Just from this diagram and from the information that they give us in the question stem.